Hi, I'm going to give Meta Hacker Cup in 3 minutes. Starting in 2 minutes, I'm sharing my screen. I have everything prepared. These are just some commands, okay? These are my golden rules. Solutions are simple, proofs are simple, implementations are simple. I have to keep them in mind and I have to look at the problem for what it is. I have to look at the problem very well. That's what I have to do in the contest. I have to look at the problem as good as possible because if I panic, that's bad. It's a 3 hour contest. What I have to do is I have to come in top 500. Sorry, top 5,000 to advance to round two. I don't know how many Indian cheaters are there in this contest, right? What 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 if first top 600 we get 6,000 Indians scamming and cheating in first 5 minutes? What if they do that using some AI? Anyway, even if they do that, I want to get within 500, 5,000. Okay. Uh-huh. Mm, 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 mm. We have four problems. A is an easy one, so I'll first go on A, and then I'll go on B, and then I'll try to think of the remaining problems a bit more. I'll try to think. I will read both of them. Is what I mean. Okay. Registered for human track. I don't know how AI leaderboard gonna be. Okay. And I also hope no one is what I can say all those things. Starting in 50 seconds. About to start. Let's see if we can enjoy the problems. Let's see if I can get top 5,000 or 500 because I want to advance to round 2 too, right? I want to advance to round 3 too. Okay. I have advanced to round 3 in 2023, but then I missed the contest, which is very bad. I know placements are going on. I had a fight in home. I can say all those things. I see. I see. Even probably they're easy. Okay. The problem shares similarities with chapter 2. The ground cannot be used. Solid Snake is back at work scaling metal platforms. This time he's bringing his own ladder. Solid Snake needs to inspect end platforms, number from 1 to n. The ith platform is a horizontal line from I comma AI to AI plus 1 comma AI inclusive. So I one will be at height AI, I to I plus 1. Solid Snake starts on platform 1. He can travel between two platforms with a ladder of height h or greater if there exists a vertical line of segment of h that intersects both the platforms. He can travel between two platforms with a ladder of height h or greater if there exists a vertical line segment of length h that intersects both the platforms. I get it a bit. Okay, I get it little bit. Okay, we cannot use in this problem. I think it's minimum adjacent distances, right? That's it. Two minimum of adjacent distances. So this problem is an easy one. Oops, I should have had some template. Right. Maybe I'll go to Hacker Cup practice round, and then I will open this one to copy just this template. Int answer equals to 0. Scene a of I. If I answer equals to max of answer comma absolute of a of I minus a of I minus 1. C out answer and L. So this should work for A1. So I think this is the answer. I'll just try to submit this. Okay, it has been valid. We got the validation output. What should we do? We have to put validation output. So for that, what should we do? I have my command that says what is the input? Snake. What is the output? I'll try to upload this validation output. Validate. We have 5 minutes. To run this one. A chapter 1.cpp. I think I'm good with that. Let's read A2. What is A2? Okay, there is ground it seems. Solid and additionally solid snake may travel between any platform on the ground if, if its ladder is long enough. Ground can be molded as a segment from what is the question? What was the question here? There is no ground, so we have to go over everything. Go over everything. Okay, but here we just have to touch everything from the ground. Okay, so we are given ground. Okay, maybe we can binary search on that length, and once you binary search on that length, many things will become connected, right? Many things will become connected, and then what you should do, you have to see They either come from ground or they have to be connected adjacent, right? Okay, so some of the adjacent things are connected, and then some of the adjacent things are connected, and then some of the adjacent things are connected, right? If these two adjacent things are not connected, this must be coming from ground. So I think to come from here to here, to come here, it's either you come from here or you come from ground. Two options, right? If you're coming from here, you have minimum of these two. Otherwise, you have minimum of these two. So minimum of all any of them will work. Okay, to come from there to here. So I will try to use almost same code, but what do I do? I'll do minimum of these two things, comma, ground is at 0 comma 0. Okay, a of I. Either you should be able to come from ground or you should be able to come from I minus 1, right? So this is going wrong. Initially we are at ground. Initially we are at ground. So answer equals to a of 0. Initially we start from else answer equals to, this doesn't seem good. If I equals to 0, answer equals to a of 0. Okay, initially a of 0. That you must do that. But 1 minute, you can use ladder and then you can go back to, right? So I think we cannot do this. We have to binary search. Otherwise it becomes complicated, right? Let's just do binary search, okay? Int left equals to 0. 0 is impossible. N is greater than 1 and you have at least one ladder. Right equals to 29 plus 1. While left not equals to right minus 1. Okay. Bool check of vector int and a comma n comma h. Okay. Int mid equals to left plus right by 2 if check of a comma n comma mid. Right equals to mid means h is possible, else left equals to mid. Int answer equals to right. See out answer. I have to be quicker, I guess. I have to be quicker. Otherwise, in all the Indians will cross me. Otherwise. So now what do I do? For int I equals to 0, I less than n I plus plus. Okay. in j equals to I plus 1, while j less than n, and absolute of a of m minus a of, sorry, and this one less than or equals to h, I'll do j plus plus. So now we are at j. So now I to j is included. Okay, I to j is included. Int min equals to a of I, let's say, for int k equals to I, k less than j, k plus plus, min equals to min of min comma a of k. Okay, if min is greater than h, return. So this is the connected component, right? You cannot use that to come here. And one of them should be less close to ground. False. Return true. And then what should we do is to start from I equals to j minus 1. So that we start from again j when we do plus plus. And then we are good. Let me run this one. Okay, this one has passed. Now we have to validate the input and then we have to submit the problem, right? How can I do that? Downloading validation input. clang plus plus std equals to c plus plus 20 b, sorry, a2 cpp. Yeah, it got compiled. You limit as unlimited. Now what? What is the name? Okay, I have to choose the file. So instead of validation, it just says chapter 2 input.txt, and then I'll make it final. I'll run it again. So those two are done. Now we are at B1 and B2. Let's read the B1 and B2 problems too. C and D also should be easy if B1 is easy. Meta employees loves two things: building cool products and scaling them up. As a new intern, you just started work on a cool. You just started. How am I looking, by the way? I don't know. As a new intern, you just started work on a cool product, but you want to make it even cooler during your internship. Initially, your empty product has coolness 1. Each of the next 2 times 2 and days, you will make a change, multiplying your product coolness by any positive integer of your choice, subject to the following requirements. After the first end days, the coolness must be at most here. You're new, you're new to code base, so you shouldn't scale too quickly. Okay. After all the 2 should have coolness exactly be. You have 1. Why can't you just multiply 1, 1, 1, 1, and then make it a? I see. I went for Susu. Just keep it 1, 1, 1, 1, and then make it B. Na. At most A will be satisfied. And then make it B na on 2 end day. So keep all 1 and then finally make it B. I don't really understand why these problems are this easy. I'm scared now. This seems correct, right? What is the problem? Final product chapter 1 validation. So to upload b1 dot final output b1 dot txt. Okay, but if the validation is correct, can it go something wrong? No, it cannot go wrong. It's a simple problem. The fuck is happening? I'll just verify one thing to be careful, to not fuck things up. I'll just verify case still 50. You have 50. Okay, I have verified that. Now what should I do? Final output b1.txt. I should not be uploading b1.txt. I should be uploading final output b1.txt. I should be uploading b1.cpp. What have I done here? to be careful. Okay, now this is 10 points, means this 23 points also doesn't mean anything, right? Please calculate how many sequences of Boolean exist that yield a final product coolness B while ensuring the coolness of utmost A after day N. All of them are like divisors of B, right? Can 140 into 10 power 7 run? So we have divisors of B, okay? Okay, we have root of D divisors, which is equals to 27 divisors at max for D less than or equals to 1e14. Okay, number of divisors is very less. Number of divisors is very less. In O of this much time, you can get those divisors. Okay, and now it's just a, so you can see values of B2 instead of what has applied. Okay, so it's just a sequence such that bi divides bi plus 1. Okay, so let's just have above thing satisfying less than or equals to n starting from 1. So 1 to n, let's have the answer, and then for each, and then you have to fix the other thing too. Okay, but the n is fixed here. Now you start from b, and then you find this value for length n plus 1. For length n plus 1, find ending with this, ending with that, ending with everything. Okay, so the complexity is n times of divisors. I think divisors will be of n is 16. Things are getting scary. Fuck, is this a difficult problem? Now look at, okay, now as n is big, now look at prime factorization. Okay, for each prime p1, it should be some increasing powers, right? This doesn't seem that easy to me. Let me see scoreboard. Okay, this seems easy to me. This seems easy to me now. Yeah, this seems easy. Brute force. Yeah, I can do this very quickly. Brute force on V of n. Okay. Once you have it, look at its power representation. Okay, if you look at its power representation, you have it would be p1 power a1, p2 power a2 up to so on. Okay, and then you have in b p1 power b1, p2 power b2 up to so on. Okay, so now what is this a1? This a1 can independently come from 0 to a1, right? So it is just 0 to a1 summation. Okay, you know the sum is a1. You have to solve the problem from 0 to a1. Here it should be a1. Okay, that means you have the summation should be that. Okay, means you have 0. Here it is 0, means you have some positive integer x1, x2 up to so on xn, all of them greater than or equals to 0. Some of them equals to a1. Okay, in the other case, y1, y2 up to so on yn greater than or equals to 0, some of them equals to b2 minus a1. Okay, that should be the power, right? b1 minus a1. Okay, sum of things being equals to this can be seen as add n minus 1 lines, see a1 dots, add n minus 1 lines in between. Okay, a1 is small, see a1 dots, add n minus 1 lines in between. Okay, so it is n plus n minus 1 plus a1 comma, and then you choose positions of whatever a1 or n minus 1. Okay, again n things are there here. Again same thing, n minus 1 plus z equals to, let's say, But then we have to see for 1e7 we should get all the primes. Can we hold such big arrays? Can I hold 1e7, an array of size 1e7? We must. Wait a minute. Let's just have it. Primes less than or equals to 1e7. Number of primes less than or equals to 1e7. I think Googling should be fine. I should not see it AI, I think. We have these many primes. This into 140 should be fine. Okay. That into 140 should be fine. If it's a prime, go over all its push it to this thing j less than n, j plus equals to I. Will this run? It's running. Now we have primes. Now we have n, a, b. Long, long. Should I do LL? It's fine, I can use long, long. Sin NAB. Okay. But we need all divisors in anyway, right? How to get all divisors? Should I just do root thing? I'll just do this one. That's the simplest one, okay? This will give us some prime now. This will give us some prime. Let's just collect all the divisors, okay? Once we have all the divisors, okay, let's also have all the primes of P. I don't think I need this because now my solution is different. B primes, okay, primes in B. Int x equals to B while x not equals to 1. I'll also maintain a map. It's fine. This is NCR, right? We are good with that. And then what do we need is n plus r minus 1 c r is what we need. N minus 1 plus a1 c a1 is what we need. Okay. So now it's simple. We go over d. Okay. Div. And then we go over p. For this d, we have our answer equals to 0, and then we have our int cur equals to 0 with d. Okay. With d, how many things are there? With d, you have one thing, let's say. D should be less than or equals to a, right? Continue. Why? The order is not like perfect order, right? The fuck? I can't be making such mistakes, right? B by D. Be very careful. Drone. B primes. Okay? Now what? I want A1. Int A1 equals to 0. Okay, I want int A1 equals to 0. B1 equals to 0. Okay. Int x equals to d while x reminder p equals to 0, x y equals to p, a1 plus plus, while x equals to b, let's say, while x reminder p equals to 0, x y equals to p, b1 plus plus. We can assert that b1 less than or a1 less than or equals to b1 here. And then what? Cur times equals to NCR of n minus 1 plus a1 comma a1. Cur reminder equals to m. Cur times equals to NCR of n minus 1 plus b1 minus a1 comma b1 minus a1. Cur reminder equals to m. Answer plus equals to cur. Answer reminder equals to m. This should be long, long. This should be long, long. And then we output answer. I think this is done. This is good enough. This is correct. So let's try running this thing. 3, 12, 6. We are perfect. I hope we are perfect. It's passing to. Now, let me review for any modulo things that can go wrong because NCR long, long, answer 1, everything will go perfect. Okay. Long, 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 long. It's like gog, gog, gog. This seems perfect. Okay, we have to be very careful. Yeah, I'm not inserting a prime. That fucking thing may go wrong, right? We are not inserting a prime. If x, wait. This is fucked up. This is not the way you determine primes. What you do instead is for int I equals to 2, I less than or equals to x, I plus plus if x remainder I equals to 0, then this prime has divided that, right? While x remainder I equals to 0, x by equals to I. Okay, this prime has divided that. B primes dot pushback of I. Now x has been reduced. So that is the first smallest prime that has been divided. X has been removed. So she can still go and find the next prime now that divides this shit. Seems correct. If x, okay, now we have all the primes. This is perfect. X not equals to 1, we have to add that prime. This should be long, long. D should be long, long. Because we're doing D square, right? Divisors can be int. No, divisors should be long, long. Okay, divisors should be long, long. Primes can be integer. Everything else should be long, long. We have to be very careful. Solving the whole problem and then fucking it up at long, long is difficult. Is very sad. So power, everything is long, long. Everything is long, long. Everything is long, long. Everything is long, long. I don't see int here. I don't see int anywhere. Okay, let's just make it long, long too. Even though it's not needed, let's just make it long, long. Who cares? I have only didn't do long, long because I thought this will be big. Okay, that's the only fucking reason I haven't done that. Primes need not be long, long, but let's just do that too. It's fine, I guess. Yeah, they should be long, long too. Primes also should be long, long. Because some prime can be greater than 1e9, right? Fuck, everything should be long, long. No integer at all. Long, 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 long. Because of this thing, they should be long, long. Everything is long, long. There is no integer at all. I think I'm safe with this. So now I have to validate it. What is it? B2, right? Seems it's taking time. Fuck. What is happening? Oh, so what is going wrong here? You cannot do 1e7. Is that the reason? I'm fucked. I times I less than or equals to. I hope that's the reason. I hope that's the reason. I hope that's the reason. If it gets validated, I think it cannot be zero. At least one is possible, right? It cannot be zero. Case 5, take it. It cannot be zero, whatever happens. That is wrong. Why is it being zero? Answer plus equals to curve. So A1 is 0, B1 is 1. Right. I haven't checked that. Just make this also long for safety. This should be correct. Fuck. There is this risk of not being able to run 140 things. Then what should I do? Then should I split and then upload them? Or should I increase the timer? Let's just say God decides this. I've done the work. Now it's not in my hands. Whatever happens, happens. I hope it runs within time. Please, God, help me get this accepted. 140? 140. I hope these things are fine. I hope these things are fine. So now these two also should be easy. If this easy problem itself is at that place, right? Rank, I'm not being that good. I should do all. I should do all. There is no backing down now. Oh, my screen is there. It's there. Robert Jr. just got a massaging down features so they can fit into what winter jackets. Frequently, Robert is given an array of feathers with initial heights h and stops on h, which he needs to flatten, that is, massage until all feather heights in that array become zero. To do that, he can perform the following operation of for cost fun as many times as necessary. Pick an integer I and any positive integer x, and both hi to okay, you can XOR these two things with x. That's what you can do. Okay, seems fine. If it is not possible to make all heights to zero, I like this question. I can solve this question for sure. By applying the operation any number of times, then cost is the length of the array m. Given an array A, determine the sum of cost to flatten all contiguous subarrays A. Formally define f of h to be the minimum number of operations required. First, we have to simplify f of h, and then You have to calculate it over all subarrays. Okay, it's a good problem for sure. Right. I'll go to SISO and come back, and then I'll solve the problem. What's the minimum cost? So it's like minimum set of indices that you have to choose. Okay. See, guys, the problem is solved. I can solve nice problems very quickly, right? So, what is the problem? Let's move this shit into done. Okay, the problem is done. I'm a pro, right? I'm a pro. You have first step, simplify f of h. Okay. Now to simplify f of h, what can you do? You can, okay, look at prefix XORs. In one operation, what is happening? In one operation, let's say this is I plus 1. Nothing changes. X will get added to that, 0 will get added to that, nothing changes. Only I changes in one operation. Which means, to be possible, you need, okay, you need XOR of everything to be 0. Okay, this is one necessary condition. First one, XOR of everything should be 0. And then, okay, answer is number of non zeros equals to minimum number of operations. The last element should be 0 and minimum number of these things. Okay, the problem is done. It's just done. Okay, it's just done. See, counting number of zeros is easy. Probably, right, because other values differs. Counting number of zeros is easy. So answer is len minus number of zeros. Okay, length of the array minus number of zeros is answer. Min op equals to len minus number of zeros is that. So if you can know number of zeros, you are done. Okay, so let's assume 0 is here, like this. This is like previous thing, and you have your elements h1, h2 up to so on hn. Hn is 0. Okay, and then you want number of zeros in between, right? Okay, if you translate it to some prefix ai, al plus 1 up to so on ar equals to pref, and you want number of pref in between. Otherwise, it's impossible. Okay. Then the cost is the length of the array m. If it is impossible, the cost is length of the array m. So for those cases, if I take number of zeros to be 0, then I am good, because it comes to be length of the array m, right? Okay, so for those cases, I have to just make them as zero. Like whenever it is not, it's just zero. So now let's think of these things. So you have pref here, and then non-pref, non-pref, and then you have pref here. Non-pref, non-pref, and then you have pref here. And then non-pref, non-pref, and then you have pref here. When R is at some non-pref, it's impossible. Okay, so answer is m. Answer is len. Number of zeros is zero. So you just not have to add anything. Like you should not consider them at all. In if you are counting number of zeros. So now what is the answer? If you have this prefix, the answer is when you consider this prefix, the answer is okay. When you consider this prefix, answer is this prefix minus this prefix. So only when R is this and L minus 1 is this, only then it works out. And then what's the answer? And then what's the answer? The answer then is 2. Like the difference in indices. Okay. So let's say if you have jet prefs, okay, when this is L and this is, choose any two of difference 1, let's say you're choosing of things of difference 1, then what is the answer? You have 1 plus, including this there are jet prefs, let's say, okay, including that there are jet prefs. Answer is 1 plus 1 times of z minus 1. Okay, you can choose these two, you can choose these two, you can choose these two, plus 2 times of, because here is answer is 1 0. If you are taking these two, 2 times of z minus 2, plus up to so on. If you're taking this and this, it is z times of 1. See, it's working out. No, it's not working out. So these are z prefixes, right? So z minus 1. So if you have z prefixes, this is the answer perfectly. And what is sum of lengths? What is sum of lengths? What is sum of all the lengths? What is sum of lengths? Sum of lengths is what? You have 1 times n plus 2 times n minus 1 plus, so let's call this function as f of z, okay, then and so on n times 1. So this is just nothing but f of n plus 1, okay. And what is f of z? If you have z prefixes, whatever we need, what is f of z? It is 1 to z minus 1, right? Summation I times z minus I equals to 1 to z minus 1, which is z times I minus I square. Okay, you have to keep z times summation of I is n into n plus 1 by 2. Okay, this is one thing. Minus summation of I square is n into n plus 1 into 2n plus 1 by 6. What is 2 times z minus 1 plus 1? 2 times z minus 1 by 6. Okay, let's take some things common here. We can take z minus 1 common. If you take z times z minus 1 by 2 common, you have 3z minus 2z minus 1 by 3. So it is z times z minus 1 times z plus 1 by 6. Looks very nice, right? Looks clean and nice, right? We can verify this sheet if we want. Keep z equals to 1, z equals to 2, keep z equals to 2 and see the values becoming 1. Okay, keep z equals to 2, the values are 1. Perfect. Probably perfect. So that is f of z. And what can be the values? Long, long. Even if you take 3 times, it's just long, long. 10 power 6 whole power 3, 10 power 18. So we are good. I want to remove this, okay? And then I will take, this is a easy problem to me because I'm a pro, right? You guys don't know that I'm a pro, but I'm a pro. This is very easy, direct to me. Probably that's why my rank is higher, okay? If I solve this, maybe I'll get little bit of better rank because this is an easy problem to me. We have z of those things, right? Int answer equals to capital F of n plus 1, okay? See out answer minus equals to capital F of z. If I run this, it will pass and then it will accept. Simple solutions. I know I'm good. Simple, small, cute solutions, right? I know cuter goes, but yeah, these solutions are also cute. So now what do I do? I'll validate it first, okay? How do I validate it? I'll click fine. Like I get scared of this shit. I'll just make it then def and 1, 2, 3, 4, 5, 6. But if it doesn't run, then I have to make it vector. In the beginning of the contest, I heard vectors are better. So let me make it vector int pref of n plus 1 so that stack memory will not overflow, it seems. So now we validate. All of us need some validation, right? In general. Here it's even more important to validate. Why? I hope I'm adding correct outputs. Everything is long, long. We have definite long, long. This will fall within range. Answer is perfect. Answer is very clear. That scared me for a moment. How many test cases do I have? 90. And how many test answers did I get? 90. All of them looks fine. Some of them are big, but they should be fine. Final output. I have to upload final output, guys. Be very careful here. We have to upload final output.txt. I think deleting validation is a better choice, right? This one got instantly solved for me. Instant solve. 24 points, which are like instant. Because they are smart, right? So that's why they are instant, okay? Instant solve. I should now they may have many solves. We have 1 hour 34 minutes to do. Strayandre is at 14. He's finished his job at 2 over 8 minutes. Can I do D? Why can't? C was an easy problem, right? Alice and Bob are back at their favorite restaurant and name some dim sum. They're sitting on opposite sides of the table with Alice on left and between them are n plates expressed as string, each containing either almond jelly or BBQ bao. Alice is hungry only for almond jelly and Bob is only for. They make turns eating as follows. Alice will start, select an almond jelly plate of her choice and pull on the very long tablecloth until the plate is in front of her, sending the prefix of dishes before crashing to the ground. She'll then eat the jelly. Bob will select a barbecue plate of his choice and pull the tablecloth until that plate reaches. Probably the bots are submitting millions of submissions to get easy problems right. Okay, I don't have good hairstyle, but I have muscles though. Not big muscles, but little bit of muscles. Someone was telling me I shouldn't be doing this. Why not? I have better lips, nigga. I will do that. If on no dishes of them, they will skip their turn without doing anything. Each player wants nothing more than the satisfaction of eating the last remaining dish on the table. Okay, they're fighting for the last dish. It's a good problem again, guys. Let's move this shit to done. I hope I'll get. I hope I'll get within 5,000. If some errors happen by mistake, some errors happen. I hope I will get within 5,000. Okay, because then I cannot give round two. That's sad, right? A bit. We have A B A B B A B. Someone Alice can remove a prefix ending at a. Bob can remove a suffix ending at b. Okay, if it becomes all a first, Bob loses. If it becomes all b first, Alice loses. Who goes first? Wait a minute, this seems so easy. I don't get it. In this case, Alice. In this case, Alice. Wait, if lost value is a, then Alice wins. He just eats everything in the first. He just pulls everything and eats the last one. Too cruel people. Else, the last one was B. Then what will Alice do? Then what will Alice do? If the last one was B, then Alice must make sure that there is an A before B. Alice should make sure that. Bob should make sure that there is a before every B. So it should start. Alice should make sure that it should start with A. Bob should make sure that it should start with B. Okay. So you have some A's, you have a B. Then let's say you have some B's, and then you have an A. Let's say. Okay. Alice should make sure that these things exist. Okay. Alice should save these things. Alice should not be removing these things. If Alice removes everything, now he loses. Alice should wait for Bob to remove these things. But why would Bob remove those things? No, Bob won't remove those things. But Bob removes. So if you see this A comma B, changes of A comma B. Okay. Whoever removes those things, they will lose. Whoever removes those things, they will lose. Okay. If Bob removes this B, he will lose. If Alice removes that B, she will lose. If it is A B, but those things remain. If he removes till here, if he selects any of this thing, he will lose. Okay. So other than that, how many choices does Alice has? We have these ABs, okay, the things that matter. We have these ABs, in between things doesn't matter to anyone, okay. Alice can remove all of these things, but then Bob loses. If this is 0, lost BBs or 0, then Alice can remove all, okay. So people will fight for in between things, I guess. People will fight for in between things, and once the in between things are over, now it's their turn to remove something. What are in between things? They're all B's. S. You'll be fine if you remove that. But let's say who first in between things became 0. Okay. Now in between things became 0. Now is my video there? Is my screen there? I think I'm getting somewhere. I can solve this problem. If in between things are 0, now let's say Ali's turn. What will she do? She will. I think also these things play in the same part, right? So all of them became 0, let's say. All of them became 0, then what will Alice will do? She must remove anything and she loses. Okay. So other than these things, if it is even, Alice loses. Else Bob loses. Is that it? Is that it? But then it should not be that it. It should not be that it. It can be that it, right? Because okay, okay. Alice can remove this thing. Alice can remove that thing. And then Bob can remove. After Alice remove this thing, what happens? Oh, okay, Alice removes this thing. Both of them will be gone as a single thing, right? Then whoever will be left with the lost A comma B, they fucking lose. Okay, it is parity of if no AB, then Alice wins. Okay, it's some B's and some A's. He pulls the last one. Else, it's parity of everything plus AB's. If these things are odd, allies loses. If these things are even, allies wins. I'm done. Parity of this is nothing but parity of n plus number of such a comma b, right? I'm adding them again, so n plus number of such a comma b. So we have int n, scene n, string s, scene s. Okay, int answer equals to n reminder 2. For int I equals to 1, I less than n, I plus plus, if s of I equals to s of I minus 1 equals to a and s of I equals to b, answer XOR equals to 1. Okay, see out answer. If it is odd, Bob wins. If it is even, Alice wins. Okay, int present AB equals to 0. Present AB equals to 1. Okay, AB is not present. Present A equals to 0. If S of I, for scarce C, S, if C equals to A, present A equals to 1. Okay, first thing, if not present A, see out Bob written. Okay, A is present, but there is no AB. Let's say means there are BS, but there is no AB. Means last one is 1 minute. If S of n minus 1 equals to A, then Bob wins. Okay, now last one is not A, means we have some B's. Okay, and there is some A, means there is some AB. If there is some AB, we have our answer here. AB, AB, 3, 4, 5. I have to be careful. The problem is not just that. AB's right. If at some point, if some between A to B becomes all S, okay, then Alice will remove this thing. If all of them were B's, okay, I think something was not adding up because this condition itself says something is not adding up. How to solve the problem? You have some B's, you have some S, right? Allies can remove these things. Allies can remove these things. Allies can even remove from here. But once Allies removes there, the problem continues for Bob on this suffix, right? So let me write states. Allies. Allies is winning here, okay? Allies is losing here. Whatever Allies removes, okay, now if this is the case. Allies loses. So now what else is there? So that means there is only one. One minute. Allies can only pull S, right? Allies can only pull S. So Allies cannot touch this. Bob cannot touch this. Anyone that touches this thing loses. If Bob pulls this, he loses. If Allies pulls this, he loses. Okay, now we are again here. Allies can only pull some of S from here, right? Alex can only pull A's, Bob can only pull B's. Why am I throwing question away like my viewers? Alex can only pull A's. If there are all B's, Bob wins. Okay. If there is an A, if there is an A in between, okay, if there is an A in between, if no A outside, Bob wins. If there is an A outside AB. So outside these things, now they will fight for, after you remove that, there should be only one B. So only one B's and some A's. Okay, let's think of this structure. A B B's S A B. Okay. If you have more S, A will remove one A. A will remove this thing, B must remove this thing, and then they will lose. So now it's about outside. It's about outside, it's about removing lost value. Whoever removes the lost value outside, they win. Is it the same problem again? No one touches this thing. Is it the same problem again? No, that makes this very good problem. But then I don't think it's that good problem. Right? How many people has solved it? Many people has solved it. It's not that good. It's not that good. We have number of ABs now. Use stack for this. Use stack and remove all ABs, 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 ABs. That means if you remove the ABs and then you see the problem, right? And then whatever is finally left, if it is all A's, all B's, that's the problem. String T. It's actually that problem. It's actually that difficult. You remove them and then you do that, but then stack makes it easy. Once you remove all ABs, whatever is left, it's a nice problem. Now there are no ABs. Okay. Because there are no ABs, it's B's and A's. If this happens, Alice wins. If that doesn't happen, it's all fucking B's. Now we validate. I hope I qualify. And then we upload the validate one, which should be called output d.txt. If it has been validated, I hope nothing goes wrong, right? Nothing goes wrong. If n is A, all A's, Alice wins. If n is B, all B's, Bob wins. Start the timer, copy that shit. I hope I am updating final outputs. Just we had 95 cases, and then how many test cases were there? 95. So here we go again. Final output has been uploaded. I can review my video. Do, 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 do. I mean, these are easy problems, but still, I'm proving very clearly. Do you guys see I removed ABs and then I proved the problem? See that? We have to be careful. Yesterday, a day has passed. I'm scared. Dcrashcourse.cpp. That's the name, right? Mm, 282 people has solved all the problems before me. It's fine for today. Some solved very quickly. I took too much time. At least I solved. Problems are too easy, probably. I'm ending the stream, guys. I have important things to do. These are bad, best, useless.